So, thank you, Lord Schaffers. I think it's the first time in my career that I got introduced by a Lord. So, let's see. Next year you have to top it up. Huh? So it's a pleasure to be here with you guys again on the stage. I mean, we were here several times in the last few years since we are working with C3. And now we want to give you a bit of update where we are on our journey, what we succeed to do, how fast we scale, how fast we get benefit, and the learnings we get out of it. Huh? With that, let's go into it very briefly, who we are. I mean, we are the largest cement manufacturing, like Lord mentioned, but we are much more than that. We are into pretty much any building material industry. We create or we manufacture everything from the roofing to the walling, to the insulation, to the ready-mix, precast, pretty much anything you would need to build a modern, efficient building. Yeah? We are investing heavily in merger acquisitions. We are investing heavily in innovation. We get several innovations granted by EU and different organizations worldwide. And we are investing also into circularity. We are doing the construction demolition waste, using alternative fuels, so pretty much anything which would help us to reduce the impact on the raw material we are using. We are roughly 45,000 people worldwide in pretty much all the continents, and we have a very distributed organization. Back to the slide from Jim this morning, all of our P&L leaders are empowered to make decisions, to run their operations, to run their markets by themselves, and we are trying to provide them the technology stack to make the decisions done better and faster and run it more efficiently. Yeah. Now, our strategy, as I mentioned, it is built around bringing the value and having high-performance culture, but in the same time having sustainable products which are helping to the planet, not just to the shareholders. And this involves several aspects which are very important for us as an industry. We are going through the huge transformation beyond just being manufacturing, introducing new materials, new fuels. Our operations become way more complex, and this all requires the next level of technology to actually run it efficient, cost-efficient, but also profitable. So, looking into more details now, what we do here is we run Industry 4.0, or name it however you want, program, which is transforming our operations in the plants. And this is one of the largest programs in this sector. We are covering with that basically all of our operations in Holcim, in all 43 countries, in all of our plants. We have at this stage more than 6,000 people which are using various products from the plants of tomorrow. And many of them are based on artificial intelligence and similar data products. We do have so far 2,300 various deployments of various applications in our plants. And this involves pretty much everything from the digital products to the robotic, to the drones, to anything which would make our operation more efficient. And all of this is running a portfolio of more than 50 different products, which are all basically connected to each other and serve not just as a data source, but also as a way of making our operation more efficient. Yeah. Now, if we look a bit more into details, what does we have in that program, you will see that we are quite technology agnostic. We are not using AI as a solution for everything. We are trying to find where different technology fit the best into problem that we have in our business, and then we are applying this technology without too much of influence from the hypes, etc. Now, saying that, AI is a core part of plants of tomorrow because pretty much everything we do is either using or generating data. Now, this goes in the terms of automation as we know it, and automation of process in the plants, quality control, etc., but also bringing robotics, drones, things which can help replace workforce into our, let's say, safety critical or not so friendly environment, which would not be so nice to have people in. We also work a lot into advanced process control, including bringing the AI on the edge in the plants, which would help stabilizing our operations, our kilns and mills, particularly with consideration that we have so many different materials and mixes that we now need to control and to use. Now going beyond that, for AI or for any kind of technology products, data is the critical thing. And data in our case mean basically sensors, mean instrumentation in the field, mean basically anything that we put into operation which dispatch data. That's why we put a lot of efforts on the industrial Internet of Things, or basically putting smart sensors, wireless sensors in our operations and having them connected within the plants, but also to the cloud and using finally the platform like C3 AI. Now and then, on top of that, we do have a lot of analytics, traditional analytics if you want, anything that we can hand over to our operational people to use basically to understand better what is happening into their plants and to act upon that. And then finally, there is a layer of AI in general, traditional ML, computer vision, generative AI, or anything which is using this vast amount of data we have in our plants. And if you look a bit more into details of generative or AI in principle, I mean, this is in the core in pretty much all of these products. Be it that we use AI, which is embedded into our drones, which is basically coming from our vendors and suppliers, or the AI that we build as a self-service in our plants, or if you want an enterprise-level AI like we do with the C3 AI, we all put this into several categories that we are addressing into plants of tomorrow. Still, probably the most beneficial for us is predictive AI. This kind of very much correlated to the slide that Nikhil said. This is basically where our biggest applications and the biggest benefit for the operations are. There we are running predictive maintenance, process optimization, quality control optimization, so stuff which are basically core of our operations, and we are just adding the layer of AI on top of it to make it more efficient, more precise. Then we do have another large bucket, which is computer vision. I suppose most of manufacturing use it one way or another. We are having a large amount of materials. We talk about millions of tons of material going to one single plant during the year. And it's not anymore, let's say, unified, stable material. It has a lot of variation. So we cannot control it in traditional ways. We need to put computer vision to actually understand granularity, consistency, flow of these materials, and this is what we put in the plant. But then, of course, we also use it for the various operations in health and safety, in maintenance, and other things. Now, the new part on it is also generative AI, and we are putting different kind of, if you want, agents or generative AI bots on top of existing products, mainly driving the whole, if you want, availability of insights on particular events in our plants with more information. So moving from just predicting topics to prescribe what actually we can do about this topic and give advice to the people how to act on it. And then last but not least, no matter how much these systems are intelligent, we still need, on the end, a human being who is looking into all of this and making decisions. And that's why we are empowering them with the powerful analytics tools, so they can drill down into details, looking into charts, time series, or whatever they would like to see before they make final decision to act left or right or up and down. Now with that, I would like to invite on stage Jorge Gamarra, our head of maintenance technology, to give you a bit more details about what we have done in the area of predictive maintenance. So, okay. Yeah.
Thank you, Marjan. So now I'm going to explain what we are doing in maintenance and how Holcim is transforming maintenance using AI. So it's a journey that we started in Holcim some years ago, and the intention was to have a machine completely monitoring with a system which is telling us where we have the problems in advance. Why? We are a cement company. We have very, very big machines, very robust, thanks God, because in this way the machines are not failure. But when there is a problem in a specific machine, the cost of the repair, the time of the repairs are huge. Simple because the machines are very big. One example, before I go into the details of this presentation, is this specific machine. This is a vertical roller mill. It's a very big machine. This kind of machine is working with 2 to 6 rollers. You can imagine each roller is around 70 to 80 tons. So this is a massive piece of metal which is rotating 24 hours, 365 days. Every time that we need to repair one of these machines means days, weeks before we can replace it. So better we know in advance where is the problem in order to plan it better and avoid surprises that cause a lot of production loss and also is generating a lot of extra cost in the maintenance. That's the reason why we started 3 years ago with C3 to work in an application that internally we call mPredict, and this is the application. Basically, it's the ultimate online conditioning monitoring for our critical equipment. This mPredict is based in the reliability application from C3. We have deployed in 82 cement plants worldwide. We have more than 800 critical machines with the size that I was describing. So to give you an idea, from this type of mill, we have close to 200 split it around the world in the company. We have more than 1,600 users daily using this application to monitor the condition of the machine and planning their repairs, avoiding critical repairs. More than 3,000 AI models to monitor these machines. This is specific. You need to think that we have 6 models only to control and to check the status of the condition of the machine. More than 100 signals only to monitor one machine. That allows us to have a very clear overview of the condition of the machine. In total, more than 90,000 sensors connected to this system worldwide and monitor it 24/7, the condition of our machines. The objective is very clear. So reduce cost, reduce time, detecting the failures in advance. Avoid production loss. For us, 1 week, 1 month, depends on the criticality of the repair, the availability of the spare parts. It's make a huge difference. That's why we need these intelligent systems, which is telling us exactly and precisely where we have the problem, where is the failure. However, this is not, as Marjan was mentioned, not the only product that we have to transform in Holcim the way that we do maintenance. We have, inside the topic of predictive AI, we have other big points that allow us to go fast in the rollout, allow us to go better in getting better data, which we call mSense. This is basically all the conditioning monitoring systems, sensors that we need, and the machines come with this kind of systems to monitor the status, so mechanical or electrical status of the machine. When we talk about generative AI, to enable the knowledge, because it's not only connecting sensors and bringing signals and that's it, so we need the knowledge. So how to interpret this information that we are getting from the different platforms, from the different sensors. We have mGuide. mGuide is our generative AI solution for maintenance property, and basically is to foster the prescriptive maintenance. So what we use the generative AI is basically to tell to our people in the plants how they need to maintain or repair the machines based on the conditions that we were observing into the predict. Other important solutions that we introduced inside Holcim for the maintenance is the utilization of the robots and drones. This allows us to access to places where normally you don't go because or it's too expensive to go to do an inspection there, because you need to mount scaffoldings, because you need to have a big infrastructure only to access and look inside a specific machine. That's why we use robots and drones. We digitalize our inspections to avoid missing information, which allow us to improve our maintenance. Therefore, we have created M-Inspect. Each inspector is walking around in the plants, not anymore with the paper, it's basically with a system which is connecting not only to SAP, as well to our AI, and it's bringing all the data of the inspections worldwide to a one system. We use analytics, basically on democratization of AI, so to open the AI knowledge to all our plants, to all our engineers. We use as well the analytics to make a very sophisticated vibration analysis. So normally in this kind of things, you rely on a very expert person who has done several trainings. We developed a system which is monitoring basically all our machines and is prescripting and detecting failures and prescripting the solutions of that failures. But all of this is very nice, but we cannot forget one essential part that allows us to go faster, and basically is the connectivity. So without allowing the sensors bringing the data into our systems, the AI will not work. That's why we have invested on the smart plant network. So we extend our network to reach any part in our cement plants. And this allows us to bring qualitative data which fit our AI models. Now, let me show you a little bit more in details the architecture that we have. So our architecture is based on three basic and simple concepts. First, the architecture must be simple. We should have a lot of automation and self-service. Otherwise, we will not reach the amount of machines that we have deployed with artificial intelligence to monitor the condition in less than 2 years. So with this specific architecture, we allow us to go faster. We have a hybrid model. So we have things which are working at the plant level. We use the cloud system. We have the capabilities to reinforce our cybersecurity over the IT/OT. We have automated and self-driven DevOps. We have self-monitoring the operations. We have auto-retraining. Everything thanks to this simple architecture, because we talk about thousands of sensors, thousands of signals that we need to bring into one system consistently and cannot, let's say, stop. So This needs to be really very, very important into the concept of transforming our maintenance to really AI maintenance. But this is not the only thing which allows us to go fast. And this part, it's more related to how we manage all these projects at the same time with a very, very lean team. So Holcim, we have really a very small team that is working on implementing, developing, and rolling out all these products. Basically, we have certain rules, put it very strictly in place, which start with the governance, which is selecting ideas. So this is from really the beginning of which product we are going to roll out and why. It's selecting ideas from bottom up to top down, and then we choose what is going to be implemented. One extremely important thing that we have clear with our team is that the product owner is the product COO. So each person needs to be responsible for what we are developing and what we are putting in place. Then we have the portfolio owner, which is basically the CEO of this portfolio, and is in charge from the beginning to the end of the implementation of these products. A very strict product methodology is implemented. So we go from the ideation to the rollout, operation, and maintenance in every single product. And we always stick to the same rule. One important thing, and this is for me one key topic, is the pragmatic decisions. So we are very pragmatic in our team. So we will see if technically the product makes sense to continue it, or we change the direction if it's possible, or we stop it. So we don't spend time to go in cycles to see, okay, yes, no. It should be fast, the decision. With this type of approach, allow us to have a clear project deployment, so for each product, which is done locally managed, and we have, let's say, a general product owner. A very important topic is the definition of the business case, which is pre-agreed or certified before we start with the rollout. We measure the usage and utilization to continue it or not with the product, because sometimes we create something which perhaps is not useful at all. A strict online reporting on the progress to the plants, to the top management, and monthly reports. And the last thing that we, I think, used to stimulate between the plants the utilization of our products is a gamification of the utilization of these products. This creates a competition between plants which allow us to see, okay, really they are interesting or not on this type of products. And saying that, I will give back the word to Marjan to continue with the presentation. Thanks a lot.
So thanks, Jorge. So a few more slides and a few more key messages from me before we wrap up this session. So Jorge was mentioning that we do have a very strict way of starting and finishing product. And I think this is what is missing in many of the transformation we see, is to understand if what we have done is actually bringing value and it is useful and usable by the plant. So we are running Net Promoter Score for all of our products. And based on that, we decide actually, should we keep it, should we pivot it, or should we retire it? And I mentioned earlier, we have 50 products in operation. We have killed 228 products. So by far more POCs ideas. Even some of them reach the operation, and we still withdraw them and put them back to the workbench. Here, what you see on the chart is that we are measuring 3 dimensions. We are measuring basically Net Promoter Score, which is telling us if the business case is actually achieved. It is measuring the overall user experience with several categories of it, but it's mainly telling us if this product is useful and usable by the plants. And then the bubble size is basically actual potential benefit. So we actually see which of these products would require more or less of our attention. And it's also telling us about scalability potential. Now, going deeper into details, this is part of much larger thing that we are running in our company. I mentioned that the whole industry is going to the transformation. We are having a very big industrial transformation in place in cement part of our business. And there are few principles we are following to achieve it. This is actually quite aligned with the slides showed yesterday by a person from McKinsey. And it is driving it in the same direction. So we do have a clear strategy, which is a business strategy. And then we are applying it in our portfolio to actually use some of the technologies to address some of the most critical business problems. We do rely a lot on strategic partnership. We cannot do it alone. Nobody can do it alone. Even the guys like Microsoft cannot do it alone. So we are also finding and keeping our relationship with key partners like C3AI in order to gain the speed and the scale into our transformation. But then the topic on the bottom is probably the most important. We are addressing skills, upskilling, reskilling, trainings, etc., but also organization per se. So we reach to the point that our operating model, our workflows, our way of working in the plant, and the organization behind that are not consistent anymore. We have so much technology now in our plants, we have so much dependency on these technologies, but we still have organization from the 20th century. So we are now addressing organization which will actually embed these new technologies and use them as the critical systems in the plants. And then on the other side of it, it's more, if you want, IT part of the whole thing, or the infrastructure part. We do depend on sensors, so we are continuously running and investigating different kinds of sensors that we can put into our plants, measure more, get more insight, be it better data, more frequent data, or simply the technologies which allow us to measure what we could not measure a few years ago. And then on the bottom of it, it is infrastructure and security, which is not to be forgotten. All of this information need a proper infrastructure network, they need computing, both in the plants and in the cloud, and they need security. I mean, they need to be secure from the cyber attacks, but also from any kind of availability or reliability problems, because they are becoming critical for the way we are operating plants now. Now, looking to that, as Jorge mentioned, we are in this journey for a while with predictive maintenance. Engagement with C3 started 3 years ago, but the whole program started 2018. We have done several iterations of various products, and we have learned different things on our journey, which is probably worthwhile sharing with the audience, because I suppose you are somewhere on that journey. And what is our learning is that the problems we are facing are not the same depending where we are in the journey. I mean, it was the biggest problem in the beginning was actually to convince business that there is a value into that. And once when we went on that step, we said, okay, now we are done. But then we come to the point, okay, now we have done it in one plant, in one machine, etc. To actually go to the few others, it's not copy-paste. You need to customize. You need to understand if this what you do is actually possible to repeat faster than doing a single pilot in each plant, in each machine. And then we went to the larger point of scale where we talk about 20, 30, 70 deployments. And then we realized we cannot do it the same way we have done before. We need platforms. We need data under control. We need to understand how we name, how we use the data, and how we can basically multiply it. But even that was not enough when we reached to hundreds of deployments. Because then the organization becomes the topic. Actually, what kind of skills we have? Who are the people who do this? Do we need more SMEs? Do we need more data scientists or more software engineers or whatever? And then we were wondering quite a lot. We have been trying different organizational operating model systems until we went to the current one, which eventually allow us to scale several hundreds of things. Then we reach the next milestone, which is talking about thousands of deployments. And that we could not do basically with really powerful platform which enable automation, all this stuff. I mean, we have basically in Jorge's team 4 people, 2 data professionals and 2 SMEs. And they're running thousands of models in production, making them, deploying them, maintaining them, retraining them, connecting new data. And this cannot be done without automation. So we have invested a lot in automation in the last few years, and this is what enables us this fast scaling. Yeah? And with that, I would just like to share a few words as a summary of the whole journey so far for us. I mean, there are few things important, but probably the most important is your strategy. And your strategy is not technology strategy. It's a business strategy. It is a strategy which is basically defining where your company or industry is going. And as a consequence of that, all the things that we are doing are business-driven. That's how we decide which technology or which case we will pursue and which we will stop or pivot or pause. The other thing is partnership. We need to have partners that we can rely and which can actually add value to our stack. Not just helping us doing this, but also challenges us to do it better, faster, cheaper, if you want. And then the next one is organizational skills. I mentioned this is the topic that sooner or later need to be addressed in any kind of manufacturing company which want to sustain technology use in the factories and plants. Now, we need to measure the value, and value has several categories, like pretty much in any business. I mean, scope is one thing. We are having scope under control. We understand which things are valuable, which are not. But beyond scope, how much you can scale this and also the speed of how fast you can scale it are very important. So we have to make a trade-offs between are we going to address the most complex problem, which could potentially bring a lot of value, but we will need 2 decades to scale it, or should we address problems which are maybe less valuable, but we can scale them in 2 years? And this kind of compromises need to be done consciously, again, driven by the business decisions, not by technology or easiness of doing this thing. Then principles Jorge mentioned to them, and I think this is probably one of the core things which keep us all aligned on the same thing. It is very easy to grow into your technology stack, into your application numbers, into your various technology use, and basically create kind of Frankenstein which does not work all together unless you have the guardrails. And here we have 3: simplicity, self-service, and automation. So everything we build need to be automated by design from the beginning because we know we will not be able to maintain it manually. Everything we do has to reduce complexity rather than increasing it. So I always challenge my architects, if they want to add something, they need to remove 2 other things. There is no way to just keep adding the stack will actually help. It needs to be simpler. And then self-service, again, we are like many companies, very decentralized and distributed. So we cannot afford that our plant operation depends on the central teams or partners. They need to be self-sustainable, and pretty much most of the work they should be able to do alone as a self-service, as a configuration work, rather than a coding or deployment. And then last but not least, on bottom all of this foundation, we need the right infrastructure, we need security under control, and we need data. Whatever data means in your business, but ultimately we need to have more data to actually achieve the industrial AI and business transformation we are pursuing. With that, I want to thank you again, C3 team, to having me on the stage together with Jorge, and have a nice rest of the day. Thank you.